Today we're going to do two things that we covered in class. Again, these lectures for Presentation High School Summer Algebra 1 are not meant as replacements for coming to class and being prepared and doing your work in class, but they are meant to supplement that work and to remind you of some of the key points and some of the hardest concepts that we covered in class on a given day. So today, the two hard things that we're going to do, or the two big concepts that we're going to cover, is solving systems of equations by graphing and solving systems of equations by substitution. So let's remind ourselves what those things are, how to do them, and work through some examples. So the first thing that we're going to do is talk about solving systems of equations by graphing. So we know how to graph. We learned on in prior days how to graph single equations like y equals x plus 1 and y equals negative 2x plus 7. We learned how to graph these equations, and these are in slope-intercept form, where we have a slope of 1 and a y-intercept of positive 1 on this equation. And on the second equation, we have a slope of negative 2 and a y-intercept of, which is denoted by b, as positive 7. So we know how to graph these equations. And we know that these equations, each one of them, a linear equation has infinite solutions. Not just many solutions, but in fact, infinite solutions. And we also know that when we have two lines in space, the one that has infinite solutions may be going like this and another one going like this, despite the fact that they both have infinite solutions, they only have one common point where they intersect. And this is also called the solution to the system of equations. The system means more than one equation, and as you know, an equation is just an equation. So the system of equations almost always has a solution of one point. There are a couple exceptions, which we'll talk about later in some other lectures on some other days. But typically, two lines will intersect at one point on a Cartesian plane. Okay, so how do we find that single solution, which is a point? It is a point, which is, denoted by, some point x1, y1 in space. And we can find that point simply by graphing both those lines and then identifying the point of intersection. So these are your three steps that you'll go through to identify a solution to a system of linear equations by graphing. The first thing you'll do is you will graph both equations, graph both lines. Then the second thing is you will find the point of intersection, and you'll identify it. And then the third thing you do is after you have that point of intersection, you will check the solution in both equations to make sure that it works. That check step is very important, especially when graphing, because when you're graphing, you don't know that point is exactly on that point. It may be like 3.1 comma 2.1 and not on the point 2 comma 3. It might be just slightly off. So we need to check that answer. Okay, so I've worked through the example completely right now, so you can kind of see where we're going. But we're going to do two solutions kind of from scratch on the next two slides. But in this case, you know how to graph y equals x plus 1. You go find the y-intercept, and then you plot your slope, and then you draw your line. Similarly, to graph your second equation, you have to go to positive 7, which is your y-intercept, and go down 2 over 1, which is your slope, and then you draw your line. So that's step one. The second point is identifying the point of intersection, which we're going to suppose is 2 comma 3, because that's where the lines cross. It looks like they cross here at 2 comma 3. So that's our second point. Second step, I should say. And then the third step is we're going to check our answer in both equations. So we have to write this equation, y equals x plus 1, and write the equation y equals negative 2x plus 7. And then we're going to plug in our point, 2, 3, into both equations. So x is 2, and y is 3, and we're going to check it. Well, after we check our first equation, we do see that 3 equals 3, so that's true, so that works. And then in our second equation, if we plug in a 2 for x and a 3 for y, and we go about solving each expression, we see that we get 3 equals 3 as well. So we have found a correct solution because both check steps, both checks work by making a true statement. Okay, so let's go through solving a system, 2 other systems of equations, and we'll do it from scratch using our 3 steps. Okay, so we're gonna solve by graphing this equation, and we're gonna graph this first equation. Now notice that we can't graph this equation very easily, so we have to put it in point slope or slope intercept form. This is not in slope intercept form, so let's go about doing that. So we're gonna take 4x minus y equals 1. So let's subtract 4x from both sides. And then we get negative y equals negative 4x plus 1. And we're going to then multiply both sides by negative 1 to make it y equals 4x minus 1. So here's our first equation. And our slope is 4. And our y-intercept is negative 1. So we can graph that by saying, well, let's go find our y-intercept, and our slope is 4. So we're going to go up 4, 1, 2, 3, 4, and over 1. Up 4, 1, 2, 3, 4, over 1. And then we can go about drawing our line. Let me just keep continuing that line like that. Okay, so there's our line for our first equation. And that, again, is, y equals 4x minus 1. So let's draw our, okay. This was incorrect. So let's go ahead and rewrite this as y equals 2x equals 16. Okay, so now I'm going to have to make sure I go back and edit that. Okay, so subtract x from both sides. We get 2y equals negative x plus 16. Divide everything by 2. And we get y equals negative 1/2 x plus 8. And there we have a slope of negative 1/2 and a y-intercept of 8. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. And then we can easily graph this line. So let's do that now. Whoops. Okay. Draw our line. So that's our first step. We've graphed both equations. Now the step 2 is we're going to guess as to what we're going to take what looks like our intersection, which is right here, and that is 2, 7. So that's our proposed solution. Now we have to test it in both of our original equations. So this is our check step. So let's write 4x minus y equals 1 and x plus 2y equals 16. So we'll put our 2 and our 7 in. So 4 times 2 minus 7 equals 1. Does 8 minus 7 equal 1? Yes. Check. That works. Now we're going to take our 2 and our 7 here. So plug a 2 in for x and 7 in for y. 2 plus 2 times 7 equals 16. Does 2 plus 14 equal 16? And the answer is yes. So we have our solution, 2, 7. And we have solved it by graphing. Let's move on. All right. Well, what's going on here? We have somehow lost our graph. Why is it doing that to me? You know what I'm going to do? I'm just going to have to go out and try coming right back to it one time. And if that doesn't work, we're going to just go and we're going to make a new graph. Wow, I'm not doing a great job today, but we are going to fix our problem quickly and elegantly. And boom, let's make our graph. Let's make that a little smaller. Let's bring this thing right about here. Now we're off and running. Okay, good. Sorry about that. So let's graph these guys. We know how to graph this blue one. We're going to put it in slope-intercept form. So I'm just going to kind of do that kind of quickly. Y equals negative x. Subtracted an x from both sides, and here our slope is -1, and our y-intercept is 0. So down 1 over 0 is our y-intercept, down 1 over 1, down 1 over 1. We can kind of see what's going on here. Let's make our line. Okay, and there's our line y equals -x. Now let's graph this other guy. So we get 3y equals -2x plus 3. Notice I subtracted 2x from both sides. Now divide everything by 3. And I get y equals -2/3 x plus 1. Down 2 over 3. Down 2 over 3. Oh, what's going on here? Well, it looks like our intersection is going to be back behind us, sort of. Down 2 over 3. So let's do our line here. Looks like our intersection's right about here. Let's see if that works. That's what, -3, 3. Well, let me make that in green. Let's do it in a different color. Let's do our solution in green, a nice, I solved it kind of color. -3, 3. Now that we have a proposed solution, we have to check it. So let's put our 2 original equations down and check and make sure that our number works. -3 is 3. What does -3 for x plus 3 for y equals 0? And the answer is yes. -3 plus 3 is 0. So now it's 2 times -3 plus 3 times 3 equal to 3. Well, is -6 plus 9 equal 3? And the answer is -6 plus 9 does equal 3. Check. So we have successfully solved this system of equations by graphing. Yay! Sometimes I do this thing called a happy cat. And I'm just going to show you what a happy cat looks like. And a happy cat looks exactly like that. And we can lay down a happy cat when we get correct answers. Okay, let's move on. Now, the other kind of other way to solve equations is by system solving by substitution. Hello. Solving by substitution. Okay, and so here's our steps for solving by substitution right here. And then this is the example of us solving with step 1, 2, 3, 4, and 5. We'll go over this kind of slowly. We did this in class, so remember, hopefully you remember, took good notes on what we did, and this is all just kind of review. So you solve by substitution generally, if it's easy to solve one or the other equation for x or y, or for one of the variables, really. And in this case, it's really easy because you could solve this first equation for x or y very easily because there's no coefficient on your x's or your y's, or you have a hidden implied coefficient of 1. You also could actually solve this second equation for y, which is very easy to do. So we have 3 candidates to solve for. We only need 1. If we were trying to solve an equation like this, we could easily solve this system of equations using substitution because our x that we would solve for this term here, we only need one of our 4 variables, really, or one of our 4 instances of variables to have a coefficient of 1 to make it easy to use substitution. So I just want to be clear about that. Here we have 3, and so it's kind of overkill in a way. But as we solve this equation, notice what we're going to choose to do. We're going to just arbitrarily choose to solve for this x here. Could have solved for this y or this y, but we're going to solve for this x and then follow our steps. So we're going to solve one equation for x or y. We're going to solve it for x. So when we say x plus y equals 9 and we solve for x, that means to make it so that x equals the rest of, or equals an expression. So we got to kind of get the x by itself, and we do that by subtracting a y. So x equals negative y plus 9, so we're done with step 1. So step 2 says, take this expression, negative y plus 9, and substitute it for x in the other equation. So now we're going to go to the second equation, and we're going to plug what we have set x for, x equal to. We're going to just take out this x here, and we're going to plug in this new expression because we know that x is equal to negative y plus 9. So we can just take it and substitute it. And so that's what we do here. So we have 2x equals y minus 3, and we just get rid of this x, and instead we put in this negative y plus 9 because we know they're equal. X and negative y plus 9 are the same thing. And notice what we've done is we've gotten rid of an x out of this equation. And so now we can solve it because we only have one variable. And so that's step 3. We're gonna solve for y. So remember, we need to do our distribution. Then we need to simplify. And we come down here and we identify that y is equal to 7. So we have one of our variables. It's 7. Now, step 4 says, let's use that value of 7 to find the other variable, which is x. So we're going to go back to this original equation and say, well, if y is 7, then what is x equal to? Well, we have to plug in our 7 for our y, and we get x plus 7 is 9, so then x must equal 2. Now, the 5th step is a check step, just to make sure we got everything right. And the way that you do that is use the other equation that we didn't use in step 4, and then put both of our variables in and make sure it works. So we know that we have this idea that x is 2 and y is 7, so we think our answer is 2 comma 7. So let's plug those values in to 2x minus our other equation, 2x equals y minus 3, and just solve down and find out that it indeed does work. So we have found our answer, 2 comma 7. So let's now do this 2 more times, solving by substitution. So in this equation, I want you, if you're ready to go, I want you to pause and try yourself. Should have told you that earlier on the graphing one. Let's pause and try. Okay, so you could have done either thing here. You need to identify when you're substituting to solve for a certain variable. Well, this second equation is already solved for y, right? It has y equals x plus 7. Y has an implied coefficient of 1. So we're actually done with step 1. So now what I'm going to do in step 2 is I'm going to take my solved equation and I'm going to plug in that value, that expression for my y in the first equation. So we're going to get rid of the y out of this first equation and plug in this x plus 7. So now I have, I'll just kind of erase this so you can see it better. So now we have 2x. We're going to take this equation and we're going to do our substitution. So 2x plus 3, not times y, but times x plus 7 equals 31, right? We had 2x plus 3y, but we're going to get rid of the y, knowing that y is equal to x plus 7. And now we're down to just just one variable. So now let's do our distribution and start to solve this guy. Okay, now we're going to combine like terms. And all we're doing is stuff that we did back on day 1 now. So let's subtract our 21. We get 5x equals 10, or x equals 2. So now that's done with step 3. This was step 2 to substitute. Step 3 was to solve, substitute. Now step 4 is to solve for the other variable. So we can take either of our original equations. Let's just switch colors because we can. And step 4, take either one of our original equations and find the value of the other one. So let's go back and use y equals x plus 7. That looks easier. And I know that x equals 2. So I'm going to take my 2 for my x. So I know x is 2. And then we're going to find out what y is equal to. Well, y is then equal to 9. Now I have a proposed solution of 2, 9, an x of 2 and a y of 9. And so now in step 5, we're going to do our check step. Which one do we use? Well, we used this equation in step 4, right? In step 4, we used this equation. So in step 5, we have to use the other equation. So I'll say 2x plus 3y equals 31. So let's validate if that works. Does 2 times 2 plus 3 times 9, 2 and 9, equal 31? Does 4 plus 27 equal 31? And the answer is yes. So I have a valid solution. And what do we do when we have valid solutions? Sometimes we put happy cats. Good. The next problem is going to be another solving by substitution, and then we're going to do a few review problems to make sure that. Okay, so now I want you to pause and try. I want you to pause plus try this one. Okay. So the only thing we can solve for is this m, because all the other ones have coefficients. So let's solve for this m. That makes it easy. So in step 1, we have m equals negative 2n plus 1. Okay, step number 2, we got to substitute in this negative 2n plus 1 in the other equation for our m. So we have our m in the second equation. We're just going to take it and plug it in like this. So 5 times negative 2n plus 1 plus 3n equals negative 23. Third step is to solve for n. So let's do our distribution. Negative 10n minus plus 5 plus 3n equals negative 23. Combine like terms. Negative 7n plus 5 equals negative 23. Subtract 5, negative 7n equals negative 28. Divide by negative 7. And we get n equals 4. Step number 4, I'm going to take this equation and plug in, knowing that n equals 4. M plus 2 times 4 equals 1. So m plus 8 equals 1. M equals minus 8, negative 7. So I think that my answer is negative 7 for m and 4 for n. But I need to take the equation that I didn't use in step number 4, which is this one, and verify my answer. This is my check step. So 5 times negative 7 plus 3 times 4 equals negative 23. Is that true? Does negative 35 plus 12 equal negative 23? Well, I think it does. Because negative 35 plus 12 is indeed negative 23 equals negative 23. Michael Jordan's negative number, the anti-Michael Jordan, check. And we are good. That is a happy cat. All right, let's move on. And the last 3 things that we're going to do is do some review questions. And these review questions are just meant to help you out. And I want you to pause and try all of them. Pause and try all of these. Okay, I assume you're back. Equation of a line containing point 2, negative 7 with slope of 1/4. And if you use the point slope form of the line, you can just write that. The point slope form is y minus y1 equals m times x minus x1 with point, if you have point x1, y1. And we do. We have a point x1, y1. And we have a slope, so we can just write this equation. So y1 is negative 7, y minus negative 7 equals 1/4 times x minus 2. So this becomes y plus 7 equals 1/4 of x minus 2. If you want to write that, rewrite it, and slope-intercept form, you may do so. But it's not required. All right. B, is this line parallel to this line? Well, the question is, lines that are parallel have the same slope as we learned before. So this has a slope. This is in point slope form. So this has a slope of 2. We don't know what the slope of this line is. So let's put it in slope-intercept form. Divide everything by negative 2. So we get y equals 2x minus 50. And so this equation has a slope of 2. So we have 2 slopes of 2. So these lines are parallel. The lines are parallel. Yes. And finally, what is the slope of a line perpendicular to the line y equals 42x minus 7? And the answer is what? Perpendicular lines have slopes that are negative reciprocals. So this has a slope equals 42. So the negative reciprocal is 1/42, but negative. And so that would be our slope of the perpendicular line. Excellent. So very good. Let's move. Let's just exit this thing, and I'm going to say thank you to everyone. I had a few glitches in this video, but I hopefully edited them out and that you didn't see some of the mistakes that I made and caught and then fixed. So this was day 5. Notice some of those extra problems might appear. Very similar problems to those may appear on tomorrow's quiz. So I highly suggest that you do those. Okay. See you tomorrow in class.